Hello guys, in this video we will cover L'Hopital's rule. What is L'Hopital's rule? So when we evaluate limits, if we get 0 over 0 or infinity over infinity as a result, we need to remove the 0 over 0 or infinity over infinity case. In chapter 2 we learn how to eliminate 0 over 0, how to remove the undetermined form by rewriting the function. We used simplification techniques, taking the common factor out. If there are fractions within fractions, equalizing fractions. If there is radical rationalizing technique, if there are trigonometric functions, we use some rules. So these are the things we did in chapter 2 to remove undetermined form. In this chapter, in this section, we are going to study another way of removing undetermined form by using L'Hopital's rule. What does L'Hopital's rule say? It says if there is a division, f and g are both differentiable, limit as x approaches to c of function f divided by function g is same as limit as x approaches to c of derivative of function f over derivative of function g. So you may confuse this with quotient rule. This is totally different. We are not taking derivative of this quotient. We are taking derivative of top separately, bottom separately, and take the limit of the result. You'll get the same result by L'Hopital's rule. So we may have 0 over 0 case, infinity over infinity case, and sometimes we need to apply L'Hopital's rule more than once. So we will solve every type of question that you may face. First question, exercise question. Limit as x approaches to 3 of 2x minus 3 over x squared minus 9. When you do direct substitution, you get 0 over 0. So in chapter 2, we studied how to rewrite the function by using simplification techniques. In here, we need to apply factorization. How do you factor x squared minus 9? It is x minus 3x plus 3. So since you have a common factor, x minus 3's will cancel each other. You removed undetermined form here. Now you take limit of the result 2 over x plus 3. By substituting 3 back, by doing direct substitution again, you get the result. This is what we did in chapter 2. Now in chapter 3, we have much more easier way, easier, simpler. Let me show you how to apply L'Hopital's here. So, limit as x approaches to 3 of 2x minus 3 over x squared minus 9 is same as, according to L'Hopital's, it is same as limit as x approaches to 3 of derivative of top over derivative of bottom. We take derivative of top separately, derivative of bottom separately. So what is the result? So derivative of 2x minus 3 is just 2. Derivative of x squared minus 9 is 2x. Now I simplified my function down to 1 over x. Now I'll take derivative of this function. Okay, we take derivative of numerator and derivative of denominator separately and use direct substitution. It will give us the answer. By plugging in 3, I will get 1 over 3, the same result with much more easier, simpler way. Alright, let's take a look at another exercise question. In this question, by substituting 0 gives us 0 over 0 case. So we take derivative of top, derivative of bottom, and the result will be limit as x approach to 0 of derivative of e to the x is e to the x minus derivative of minus x is minus 1 minus minus makes plus 1 over derivative of x is 1. Now apply direct substitution. So e to the power of x, e to the power of 0, 1, 1 plus 1 over 1, which is 2. So 2 is the value of this limit at 0. Check it out question. This is one of the rules, one of the functions we used as a rule in chapter 2. The result of this limit, we memorize the rule as 0, but it's why 0? The 0 comes from the L'Hopital's rule. How? We take derivative of top, derivative of bottom separately, equalize this limit to limit as x approaches the 0 of derivative of top, which is derivative of cosine is minus cosine, minus minus becomes plus, sine, over derivative of x is 1. Now substitute 0 for x, it's gonna give you 0, sine 0 is 0. So that's my answer. Okay, now let's continue with using L'Hopital's rule for infinity over infinity form. So in order to find the answers correctly, we should know some notes. Infinity, adding some number or subtracting some number from infinity gives you infinity, it doesn't make any difference. Multiplying infinity by a number also gives you infinity, as long as that number is not 0. Non-zero number divided by infinity is 0. Infinity divided by a non-zero number is also infinity. Adding infinities gives you infinity. Logarithm infinity is infinity. E to the power of infinity is infinity. But e to the power of negative infinity, when you get rid of this negative, you move e to the infinity at the bottom. It gives you 1 over infinity, which is 0. So these are the things that you need to know when you get a convolution solving questions. Okay, first question about infinity over infinity form. So here I have limit as x approaches the infinity of x over e to the x. By substituting infinity for x, we get infinity over infinity, which means we should take derivative of top, derivative of bottom. So that's equivalent to derivative of numerator 1, derivative of denominator e to the x. Now use direct substitution. It's 1 over e to the infinity, which is 1 over infinity. E to the infinity is infinity, which means 0. Okay, number over infinity gives you 0. Okay, another exercise question, administrative question. When substituting infinity, it gives infinity over infinity. Applying L'Hopital's, let's see what we get. It's equivalent to limit as x approaches the positive infinity of derivative of this. I can use logarithm property. I can move 4 down in front and take derivative of ln x, which is derivative of the angle 1 divided by the angle. I can do that, or I can just take derivative of ln x to the 4s, derivative of the angle, which is 4x cubed divided by the same angle, x to the 4th. We will get the same result, over derivative of the bottom, which is 3x squared. Okay, now let's simplify this fraction. So it's 4 over x over 3x squared over 1, something like that. When you have the division over division, when you have fraction over fraction, you keep the top fraction, remember, multiply it by reciprocal of bottom fraction. So here I have limit as x approaches the positive infinity of 4 over 3x cubed. Now substitute infinity back. It's gonna give you 4 over infinity. Number over infinity is 0. Alright. Study guide question. Find the result of this. There is no division. How can I apply L'Hopital's? I can apply L'Hopital's by getting rid of that negative exponent. To get rid of this, I should move this power in denominator. So rewrite this function as x divided by e to the power of x squared. So no more negative exponents. Now, inserting infinity for x results in infinity over infinity. So use L'Hopital's. So this statement is same as taking derivative of top and bottom separate. So it results in derivative of x, which is 1, derivative of bottom, derivative of the power, which is 2x, times itself, e to the x squared. Now plug in infinity for x. It's gonna be number over infinity, which results in 0. Alright? Okay, what about applying L'Hopital's more than once? So when we have infinity over infinity case, by using direct substitution, we apply L'Hopital's. So let's apply L'Hopital's first. Take derivative of top, derivative of bottom. So it will give you derivative of top is e to the x itself, bottom 2x. Substitute infinity again. It's gonna give you e to the infinity, infinity, 2 times infinity, infinity, again infinity over infinity case. So use L'Hopital's again. So this time you have take derivative of top, which is e to the x itself, take derivative of bottom, which is 2, insert infinity for x, e to the infinity, which is infinity. Infinity over 2 will be infinity. Okay, see, we are just using those numbers, those rules, okay, those notes to get a result. Okay, let's take a look at a ministry question. All right. So how many times should I apply L'Hopital's rule? Let's see. When I insert 0 for x, cosine 0 is 1, 1 minus 1, 0. Cosine 0 is 1, 1 minus 1, 0. So it's 0 over 0 case. We use L'Hopital's. So take derivative of top and derivative of bottom separately. So this limit is equivalent to derivative of 1, 0, derivative of minus cosine 4x minus derivative of angle 4 times sine, negative sine cos 4x. Negative, negative becomes positive, sine 4x. Derivative of cosine 9x is negative, negative makes positive. Derivative of angle 9 sine of the same angle. Okay, this is my result when I apply L'Hopital's. Now insert 0 for x. So sine 0 is 0, sine 0 is 0. I have again 0 over 0 case. So let's use L'Hopital's one more time. So this time, by taking derivative of numerator, we get derivative of sine is cosine, derivative of angle 4. 4 times 4, 16 cosine 4x divided by 9 times derivative of angle 9, 81 cosine 9x. So by substituting 0 for x, you'll get cosine 0 is 1, 16 over 81, which is option B. Okay. So whether question tells you to use L'Hopital's rule or not, whenever the case is 0 over 0 or infinity over infinity, we can always apply it. Okay, one last question and I am done. Another ministry question. By inserting infinity, you get infinity over infinity. So you should use L'Hopital's apparently. But what about 1? There is no undetermined form here. So we can separate this. We can rewrite the limit first by writing this as limit as x approaches the positive infinity of 1 plus limit as x approaches the positive infinity of this undetermined form. Now this one will be 1. Remember constant limit rule. Whenever the function is constant, no matter what the x value is, the result is 1. the result is that constant function, plus this one, it gives you infinity over infinity. So we use L'Hopital's for this function. So take derivative of top, derivative of bottom. So it will give you derivative of ln x 1 over x over derivative of x1. So its limit as x approaches the positive infinity of 1 over x. By plugging in infinity for x, 1 over infinity is 0. So this part is 0. 0 plus 1 is 1. Okay, that's how you solve L'Hopital's questions.